And good day to you. So today I'm showing off my particle swarm optimizer. It's for finding the local minima and maxima within a data set. I've only got one particle swarm going. It took me only 30 minutes to write. It's relatively simple. It's kind of a bit of a response because I read about this and was almost going to not do it at all, but I realised when they were talking about the track and trace that this is, probably the sort of optimizers they're using, and I guess maybe somebody out there who doesn't know about these things might find it, look at the video and think, well, I'm a little bit educated on what sort of systems they're using. Also, because those people seem to be paid 25k a day. And if I can do this in half an hour, I sort of struggle to understand what exactly is going on there. Anyway, if I restart it, you'll make more sense. So this is trying to find the best distance to the dragon. The swarm's just moving around randomly. Every time it finds a better and closer value, you can see it prints down here. So it's reducing down the distance it's got to the map that it's trying to find. Now, I said about a pandemic sort of situation. I probably need to explain a little bit better on how this works. So all these little, almost directionless little particles are wandering around. They have an x and y value and a inertia value for both those values. They have it's probably easier if I restart it to show that exact what's going on. If you restart it and I run a few, the swarm tells the rest of the swarm every time it finds a closer point to the dragon. So you see there, it didn't know where it was going, it just moved around there, and then when it works out its proximity to the dragon and says, well, am I above or below or to the side of the best value the swarm's found? If so, speed up in the opposite direction. So if I'm overshooting the dragon, slow down until I slingshot back around, like you'll see with this guy over here. Slows down, speeds up, comes back round and comes around for another pass. Now, this is really not very impressive in this two-dimensional situation. Where it gets a bit more impressive is where you start talking about it, about things like, I guess you'd have it in 3 dimensions, and in the 3 dimensions, what you'd be looking at is, so if you were having an outbreak like of some disease that you wanted to do a track and trace app, so to speak, maybe you would have time reported locations of X and Y axis that the people have been to, and you would calculate centers of outbreak based on that slice of the data using these things, because this is it cycling through an X and Y axis. If it's nothing to really add on a 3rd dimension onto it, or even 4th and 5th dimension, as many dimensions as you want, and just have it have the swarm randomly cycling through the dimensions, and as it finds a better fit in those dimensions by calculating the distance to all the different occurrences and finding something that minimizes that, you're able to get it to tell you what probably is the center of that outbreak. And if you're doing it in 3 dimensions, that would be the center of outbreak both in time, saying over the last week, and also in terms of the X and Y axis. So it's for stuff like that when it's probably interesting and where maybe it's useful. If you wanted to, I don't know, like it becomes something to talk about when you use it for what the mathematicians talk about, which is finding maximum minima. Because when you're doing it like that, is you think of it less as how I'm showing it visually here, and more as it's got a bunch of variables for its input value, and you're looking to cycle through the different variables and maximize or minimize the outcome of the function that you're trying to test and try and probe. And this could be real data, or it could be mathematical functions. And this is why I very nearly didn't do this video. This is why I very nearly went, I'm just going to sound like a complete moron. I need to read up on it more. And it probably is something that I need to read up on it a little bit more to, explain it simply, explain it properly. But given the times we're in, and other things, it's relatively useful to know about it. It gives you maybe an insight of maybe just what they're doing with the track and trace data, if they're doing anything with it. It's more probable to my mind that you'd be using a k-means analysis and grouping them up into big groups and looking for centres that way. But this is a different way of doing it, one that is also useful out there, and I'm probably going to do some videos on its sister algorithms, sort of the ant swarm optimization and the bee swarm optimization when I get round to it, because I'm trying to work through all the simple genetic algorithms to gain a sort of a field of knowledge. If this wasn't the most interesting video in the world, sorry, but hopefully somebody out there learned something from it and found it interesting. Many thanks. Bye.